Alright, so this lesson is I can model and solve problems using 3D cross sections and 2D rotations. Okay, so a 3D cross section, if you think about taking a 3D figure and slicing it. So if we had taken some Play-Doh and making a ball out of it, and we were to take a knife and slice it directly in half, this little part in blue is what I'm highlighting, it would actually make this circle right here. So, if that doesn't make sense, then go use some Play-Doh, roll it up into a ball, and cut it with a knife. The section that you're going to see is a 2D figure, and it's going to be a circle. So, here's the problem. If a sphere with volume 36 inches cubed is cut directly in half, what is the area of its cross section? So, you have to remember that volume is for 3D figures, and you also have to remember the formula for volume of a sphere. So if you have forgotten, it is 4/3 pi r cubed. And remember that r stands for radius. So we know that this sphere that we built out of Play-Doh is 36 inches cubed. But if you'll notice, we don't know what the radius was, but we can work backwards and find it. Okay, also, the whole point of this is to find what is the area, I'm going to highlight it, of its cross section. So because this is a circle and it's a 2D circle, we are talking about finding area. So you have to know that the area for a circle is pi r squared. And if you hear a dog barking in the background, that's my dog, sorry. Alright, so I'm going to go over here and I'm going to get rid of this 4/3 by dividing both sides by 4/3. And you can do that in your calculator. Just make sure you put 4/3 in parentheses. So now I'm going to change it to 27. So we got rid of the 4/3. And now I also need to get rid of the pi. I'm going to do that by dividing both sides by pi. And I'm going to change this to approximate because I am rounding. I'm just going to make it one decimal place just to be simple. And then I'm going to get rid of that cube root. I'm going to get rid of the cube by doing the cube root of both sides. So let's say about 2. So now that we know what the radius was before we cut it, we also know what the radius is after we cut it. So all we have to do is plug it into pi times r squared. So we're going to get the area is approximately, let's say, 12.6. So I am rounding, and I'm also using just a simple calculator on my phone, not an actual TI graphing calculator. So it may be a little different how I rounded than you did, but hopefully you didn't round as much as I did, and your answer is more precise than mine. But you get the basics of it. So the area of the circle is about 12.6. Alright, so now we're going to look at taking a 2D figure and rotating it over and over until it becomes a 3D figure. So if that doesn't make sense, think about taking a quarter and flicking it, and it'll spin around and around and around. And so when you take a quarter and you spin it, it becomes a sphere. And we're going to use that same concept, but this time we're going to take a rectangle, and I think this actually turns out to be a square if I'm not forgetting, but we'll see. So go ahead and graph those 4 vertices. You can do it on some graph paper if you have some at home, if you can print it off, or you can just make your own on a scratch sheet of paper. So I'm going to go ahead and graph the vertices. And I'm also going ahead and connecting those vertices. And remember, I'm doing this with my fingers, so it looks a little weird. Okay, so we're trying to find what is the volume. So volume implies a 3D figure. In cubic units of the figure created by rotating it about the x-axis. So remember that this one is the x-axis. So we're going to take that square and we're going to flip it around and around and around. So if you can imagine that, it's going to look like this, which actually turns out to be a cylinder. And I know you're totally jealous of my cylinder skills drawing. Yes, I know. Alright, so if you do not remember the volume of a cylinder, it is pi r squared h. So I'm going to highlight this for you. This is your r, that's your radius, and all you have to do is count, that's 2. And then here is the height, and all you have to do is count. It's 4, and so I'm just going to write this into my formula. So pi times r squared times height, and you just type that into your calculator, and you can round to the nearest decimal place. And I just realized that I didn't write 4, I wrote 8. Try that again. So I got approximately like 50.2-ish. And that is going to be in cubic units. It doesn't say if it's in like inches or something, but if it was in inches, it would just be inches cubed. If it was in centimeters, it would be centimeters cubed. That's all that means. The cubed is coming from the fact that you multiplied some different things together. Alright, so hopefully that made sense. I'll try to post some videos about rotating 2D figures, and maybe it'll help some of those visualize a little bit better. Okay, so now we're going to do basically the same thing, but this time we're going to take a triangle. Oh, I moved it over. Alright, so we're going to take a triangle, we're going to graph these vertices, and we're going to find the volume, so it's going to be a 3D figure, and we're going to find the volume by rotating it around an x-axis. So, get your graph paper, go ahead and graph your vertices, draw your triangle. I'll tell you what, I'm going to change this point to, let's do 0. Let's do 4, 0, and make it just a nicer triangle, because this is our first time. So if we were in class, I would do it a little more complicated, but since we're just doing our distance learning, let's make it as easy as possible. So when we graph this triangle, remember this is our x-axis, and so we're going to graph it and think about it flipping over the x-axis. So sometimes what I do is I just go ahead and draw it as a reflection, and then the base where it's rotating, I just kind of do like a little circle. So that's pretty ugly, but hopefully you can see that that makes a cone. So you have to know that the volume formula for a cone is 1/3 pi r squared h, and so now we just have to find those different things. So I'm going to do r in green. R is my radius, and all I have to do is count, so it's going to be 3. And let me do h in red, that's our height. All you have to do is count, it's going to be 4. And it's pretty easy, just plugging this into a calculator. I think the hardest part is visualizing it rotating, and for some people that's easy, for some people it's not, so I'll try to find some other videos that maybe helps some of you out. So go ahead and put that in your calculator, make sure you're using the pi button, make sure you're putting parentheses around 1/3. So I got approximately, let's say 37.7. Remember, this is ish, because we are rounding. Okay, so now we're going to do the challenge. So this one's a challenge. It was on the EOC. I think it's pretty difficult if you're not great at visualizing stuff, and it's also using a lot of stuff from middle school. So I want you to go ahead and graph the vertices of this triangle, and then we are going to rotate it around this line y equals x. So if you're unfamiliar with that line, you can put it in Desmos and you can look at what it looks like, or you can use your graphing calculator, but I'll show you what it is in just a minute. Okay, so on this graph paper, don't judge me, I know it looks horrible. There's my triangle, I did it in red, and then the black line is that line y equals x. It's just a diagonal line, it has a positive slope. The side of the triangle borders with that line, that's important. So think about that triangle flipping over that and then rotating, and you should see that it makes a cone once again. And then we should also remember that a cone is 1/3 pi r squared h. So let me do some color coding. So here's going to be my r, that's my radius. And then I'm going to do it in this light blue. Height is going to be right here. Oh, that is horrible. So we cannot just count these lines because they're diagonals. So what we're going to have to do is use the Pythagorean theorem. So I know that some of you are not great at this and some of you are. So you can watch other videos about Pythagorean theorem. Just Google Pythagorean theorem, go to YouTube, do whatever you need to do. but I'm going to go over it real quickly right here. So if you look at this green line that I just drew, and you think about making a right triangle. So let me draw a little better. I'm trying to find R, this length right here. And then I know that my horizontal side is 3 units, and I know that my vertical side is 3 units. So I'm going to use Pythagorean theorem. A squared plus B squared equals C squared, but we're going to use an R because that's what we're calling it. So this is 9 plus 9 equals R squared. 9 plus 9 is 18 equals R squared. And then to get rid of a square, you're always going to take the square root. So I am going to round this a little bit. If you do it in your calculator, you get about 4.24. If you remember from previous math courses, you can think of the biggest perfect square 18 is divisible by, so it really drops into the square root of 9 times the square root of 2. So I could write this as 3 square roots of 2. So I took the square root of that because it was a perfect square, and then I can't take the square root of that because it's not perfect. So that's why it becomes 3 square roots of 2. I know that was a lot. I'm sorry. I'm just trying to get through this. So I'm going to erase all this. And just remember that the radius is 3 square roots of 2. So now we're going to do the blue triangle. And we're going to do basically the same thing. I'm going to just redraw it over here. So we're trying to figure out H, our hypotenuse. The horizontal line is 6. The vertical line is 6. So I'm going to do the same thing. 6 squared plus 6 squared equals H squared. 6 squared is 36. 36, H squared. 36 plus 36 is 72. And then to get rid of that square, I'm going to take the square root of 72. So if you remember, the biggest perfect square 72 is divisible by is 36. And then I can't take the square root of 2, but I can take the square root of 36. So H is actually going to be 6 square roots of 2. And I'm going to erase this just so I have some extra room. And I know this is a lot, but it's just reviewing some basic concepts that you've used in the past. So now we actually have all the information we need, and we just plug it in. So this is 1/3 pi. My R we found was 3 square root of 2. I'm going to square all of that. Notice I put it in parentheses. And then my H was 6 square root of 2, and I'm going to put all of that in parentheses. So you go ahead and try it and see what you get. So over on the side, I wrote like what the precise answer is, but if you were to put that in your calculator, you're going to get approximately 159.86. I'm going to put ish because we are rounding. So if you got this one here that I'm circling, you could just put that one in the calculator and match it up and know that you got the correct answer. Alright, so hopefully that made sense. So here's a little math meme. You can just breathe a little bit. Thank you for being patient and watching this video and trying your best. And anytime you need extra help, extra worksheets, anything, make sure you email me or send me a message on Remind. You can DM me, but that's a little weird, get a little crazy. Okay, hopefully you enjoyed the video. I'll see you later.